everyone, welcome to Let's Get Defensive, the show where we pit two combatants together. Two men enter, one man leaves.
Bryan, are you sure you've got the right show?
Welcome to Let's Get Defensive. Over the next hour or so, we're going to take you through some of the more interesting news items that have popped up over the last week and talk about how these projects and initiatives in aerospace and defense can be successful with proper attention to the critical thread.
And we're going to follow a slightly different format today. So we're going to be picking up a kind of 10 main articles, which I think are pretty interesting for y'all. And we're after 2 or 3, we're going to take a quick commercial break, update you with lots more news over a 2-minute period. Then we're going to break back into conversation, another commercial break. And at the end of all of that, we're then going to invite on our special guest to talk about design and change management in aerospace and defense.
That's right. Got a lot to pack in today. It'll be good.
Yeah, we're going to talk about Safran, BAE, Rocket Lab, Blue Origin, Sierra Nevada, Rolls-Royce, AeroVironment, Kongsberg, Kinetic, Oshkosh, Hanwha, and Lewis.
That's right.
So let's just dive in.
First up, the Arab Organization for Industrialization and Safran Aircraft Engines have signed an agreement to maintain Larzac engines in Egypt, marking a significant collaboration in aerospace and defense. This partnership is actually allowing AOI to become a licensed maintenance, repair, and overhaul, MRO for short, provider for the Larzac engines, which are used in Alpha Jet aircraft. The new engine shop in Helwan will employ 30 skilled workers, reflecting AOI's commitment to developing an industrial base.
Big issue here for you guys is the whole MRO side of things, the whole data integration side of things. How do you connect all of the maintenance activities within design changes, engine performance, and make sure nothing slips through the cracks, especially when we're talking about engines that have to perform under extreme conditions? Bryan, how hard is it to pull real-time performance data into the maintenance loop on something like this? Not simple.
It's harder now. I mean, it's easier now than it used to be, let's say 20 years ago, because of certain bits of technology we can use, but it is not an easy task.
Exactly. So how do we fix it? I mean, we look at 2-3 main areas. First up is AI-driven predictive maintenance. We pull in AI for something like this, integrate it with MESMOM systems, and boom! Suddenly, we now have an engine part. We know the engine parts are about to fail before they fail through this artificial intelligence. Tie it into real-time production data, no downtime surprises. Second up, we look at requirements traceability. Maintenance has to stay locked in with the original design. This is not an ERP upstream solution. This is a product lifecycle end solution. The critical thread handles that traceability. No more guessing if an update missed something important. And I guess the last thing we're going to be looking at on critical thread is simulation for validation. Before any mechanic touches the engine, AI-driven simulations validate the entire maintenance procedure. Everything's tested virtually, so nothing is left to chance. And that's how you get proactive, you save money, and keep those engines flying safely.
Yeah, sounds like you, I think, nailed just about everything.
Next up, the USS Halsey, a U.S. Navy-guided missile destroyer, is undergoing a 2-year, $177 million overhaul by BAE Systems. This was announced just a week or two ago, end of August. The upgrade is going to take place in San Diego and is scheduled for completion by April 2026. The project aims to modernize the ship's aging systems, structural integrity, enhancing combat capabilities, which is always huge. I mean, key upgrades are going to focus on the ship's hull, mechanical, and electrical systems, along with some weapon systems, command technologies, extending the vessel's operational life and maintaining its effectiveness.
You just said a whole lot of things that this is going to teach. And I think a lot of times when we think of product lifecycle, when we think of critical thread, we tend to think about just the conception, the design, and the manufacturing stages. And we don't always think about, in general, what's going to happen once this product is sold and in use and out there. How long is it going to last? How do we make it last longer? What's the motivation of the manufacturer to make sure their product lasts longer and doesn't just get replaced. Companies really need to be considering the full life of their products. And maintenance can also be a huge market if it's done correctly and keeps customers happy. So when we look at what goes into extending the life of the product, maybe even beyond what its original intentions were, because you touched on what you said: hull upgrades, mechanical upgrades, electrical, combat systems, technical enhancements, comms, intelligence. Integration is going to be the huge thing to consider here. How are you going to integrate new stuff with the old stuff and make it all work seamlessly with the testing and planning, and then the logistics to consider, because you're dealing with things that are currently active and working, and crews on these that still need to be able to go out and do their job. So you have to coordinate the dry docking without interfering with the operational duties. There's just a lot to dive into and to consider. And another place for all of these aspects that we've talked about with software handling the critical thread can come into play.
Yeah, I mean, I agree with you on the logistics that it is huge. Let's also not forget the data integrity side of things, because you've got upgrades across mechanical, electrical, combat systems. If those data streams don't line up, you've got problems, and you've got them real quick. Plus, then you've got your supply chain complexity. Delays, one missed part could stall everything. And of course, solution to that, you've got your AI, which has already proliferated across a lot of great supply chain solutions these days. And it is more than capable of handling and overlaying inventory, BOM into your supply chain, your materials. So for me, solutions to this is going to be your configuration management, artificial intelligence for config management, keeping all of those systems aligned, flags inconsistencies before they even hit you. And then, of course, predictive maintenance off the back of that pinpoints when something's going to fail before it actually does, and keeps that ship operational and extends its life. Done.
One question that comes to mind when you're talking about replacing bits and pieces of a ship and then replacing bits and pieces of a ship is, have you guys heard of the ship of Theseus? It's that philosophical debate of, if you replace a bit with something new and you eventually over time have replaced everything about the ship with a new piece, is it still the same ship or not? Which is obviously a discussion for another time.
What's it called?
What's that? The ship of Theseus?
Okay.
Yeah.
Okay.
Interesting. I'll have to dig into that some more. Next up, Rocket Lab's Mars mission has reached a significant milestone with its probes ready for launch on Blue Origin's New Glenn rocket. The collaboration between Rocket Lab and Blue Origin really marks a crucial step in Mars exploration, with the New Glenn rocket designed to carry substantial payloads necessary for the mission. I mean, this launch highlights the competitive space race that we've all seen and watched between billionaires Jeff Bezos and Elon Musk, each kind of striving for that space supremacy. The mission aims to advance our understanding of Mars by deploying probes equipped with advanced scientific instruments to study the planet.
The biggest challenge here is that seamless integration across these systems. Again, you've got probes, you've got rockets, you've got scientific instruments, launch systems, all from different teams, different companies, and different technologies. It's an integration nightmare. Bryan, how tough is it, again, to make sure that every single system communicates perfectly during something like this? One wrong signal, and you've got potentially, $500 million of space junk out there.
So if I said it's easy, that would just take you off your soapbox.
It would.
But no, it's not actually easy, which it's as you may have guessed from listening, it's going to be a difficult thing to make all the pieces work together.
It's pretty difficult, yeah. How do we avoid it? I guess critical thread, requirements, prioritization, and traceability for me. First, we need to align every system from design to payload. And the critical thread makes sure that the critical mission requirements are top priority, while traceability tools look in any changes across the board so that nothing slips through. You've got your configuration management again, but now we've got AI on top of configuration management. So that whole kind of configuration intelligence. With all these payloads and instruments out there, we need AI to track and manage every component, keeping everything optimized for weight, for performance, and compatibility. So there's no room for error when we're talking about a Mars mission. And then you've got simulation and validation. So a lot of solutions, I think, to this.
Easier said than done.
You have been mentioning AI so much that I'm like having some scared feelings of the future of the robots taking over. So I don't know about you, but I need to go refill some coffee.
The U.S. Army has awarded Sierra Nevada Corporation a contract to lead the High Accuracy Detection and Exploitation System, HADES, program. This initiative aims to modernize the Army's intelligence, surveillance, and reconnaissance capabilities by integrating advanced sensing technologies into Bombardier Global 6500 jets. The 12-year contract could reach up to $994 million, just under $1 billion. We'll keep it at that. And focuses on replacing the outdated turboprop ISR fleet with aircraft capable of flying higher, faster, longer, enhancing, of course, the Army's ability to gather intelligence, maintain situational awareness, and really multi-domain operations. It's kind of an exciting upgrade.
One challenge we like to give ourselves is figuring out what is the most important aspect of a project. And what's the best way to really make it succeed when we look at product lifecycle management, critical threat, all these pieces together. And Andrew might disagree with me on this one, but I think the most important thing here is the amazing acronyms that have been come up with. I mean, I want to work on the HADES project just because it's called the HADES, right? And, you know, our astute listener might notice that we've talked about HADES before. The Army actually awarded a contract to Bombardier last December for the Global 6500, which was going to be the prototype for HADES. And I think their plan was to field a fleet of 14 aircraft that's going to replace the entire manned ISR fleet. So they started with HADES, and they've also used the Artemis project, the Ares project. I'm sensing a theme here. But the goal of this is basically to create a new fleet of ISR aircraft with a bunch of stuff in there: the intelligence, the SAR MTI, the synthetic aperture radar, additional, all sorts of fancy, you know, equipment, and to let it do these really remarkable things. So it's a long-term project, has a lot of proof of concept built in, has a lot of planning they've done with the other projects to get ready for it. And so I think they've already shown a pretty good systematic approach to how each piece is going to integrate together, to making that testing process, which is actually what I think one of the most important things for this is figuring out how to take your existing ships and your existing parts, replace them with the next ones in a way that flows nicely and fluidly with everything else that's going on, and keep advancing the whole operation. So I think they've actually started already on a really good track, which I think shows a good, at least hints of an understanding of critical threat.
Yeah. Data is the big thing here for me. It's kind of that data integration. It's going to be the biggest hurdle I think they've got. They've got massive amounts of real-time data flowing from all of these different sensors that you touched on. That data then has to be analyzed and acted upon immediately in a multi-domain ops environment. Plus, then you've got the whole lifecycle management piece. This thing runs for 12 years, but tech moves super fast. I mean, you just take what's coming through now. Yeah. So how do you go about ensuring that Hades stays at the cutting edge? For me, a couple of things are extremely relevant. First thing is predictive analytics. AI, again, is going to forecast when the tech needs upgrading. It's going to keep that fleet ready, and the ISR capabilities are at the top of the game, even years down the line. And then I think, secondly, AI for real-time data fusion. So it brings together all of that sensor data together faster. It's going to bring it together smarter so that the commanders can get actionable insights when they need them. So a lot of challenges, but a lot of good stuff coming through, I think, to keep on top of it.
And that's how you keep Hades relevant instead of having it fade into myth and legend.
Yep.
Cathay Pacific has identified a problem with Rolls-Royce engines on 15 of its Airbus A350 aircraft following a component failure during takeoff from Hong Kong. The airline is replacing the faulty parts and expects to resume flights by Saturday. Singapore Airlines is also inspecting its Airbus A350s as a precaution, though it hasn't reported any impacts yet, which is good. The affected engines are Rolls-Royce Trent XWB-97 models. The news caused Rolls-Royce shares.
Hold a second here. This is pretty big. This is a big. How do quality control, predictive maintenance? How does a critical engine component fail during takeoff? I mean,
is it the same way that a critical door bolt fails during flight?
You had to go there. But I mean, it's hugely disruptive, obviously, and it's potentially very damaging to the Rolls-Royce reputation. We know it's hard. It is predict these failures before they actually happen, especially on something as critical as an engine. But the reality is not acceptable, is it? Not acceptable. How do we make sure that doesn't happen? For me, you've got defect detection. Rolls-Royce needs to roll out a powered visual inspection tool. I gotta say it's AI potentially. You've got to have that in there that's got those opticals that is reading during manufacturing. These detect even the tiniest of details before they turn into catastrophic failures, which is potentially what this is. Yeah. So you catch it up early and avoid yourself a bit of a PR nightmare as well. And then you've got predictive failure analytics as well, using artificial intelligence to predict when the parts will fail by analyzing real-time engine performance and historical data. So you've got all your IoT devices on your engines again. And then lastly, I think for me, material planning. I mean, you've got a huge inventory of material that's out there. You need an overlaid artificial intelligence tool to help sure that only the best materials get into the engines. So you're predicting material performance based upon past data, thus preventing the faulty components from even entering the supply chain in the first place.
I think another interesting aspect here too is once you have found that we have something that needs to be replaced or fixed, you've got to get instructions and directions out, not just the parts and the replacements, but also the actual instructions. And I think this is a really good case for using some of those augmented reality tools where you can take your tablet and actually see, here's what I need to replace. Here's the video of how to do it as I'm doing it. And those kind of things are fantastic. So that's something else, not necessarily the AI level of computer aided here, but at least the augmented reality can also play a big effect.
It is super advanced, the AR, VR, XR whole world, I got to say. So yeah, it's right up there.
Yeah. AeroVironment has been awarded a $990 million contract by the U.S. Army. What is it with these billion-dollar contracts? To supply Switchblade loitering munitions, which are essentially small portable drones that can be used for precision strikes. These munitions are part of the Army's initiative to enhance its infantry battalions' ability to hit fortified or moving targets from a distance, even without direct sight. So the contract is managed by Army Contracting Command Aberdeen Proving Ground, and follows a previous contract from December 2023 with deliveries set to begin soon. I'm excited.
Yeah, I think we did talk a little bit about some of this, I think, back in December of 23. But the idea of, well, I think first off, this might be in consideration for a weapon of the week if we still do what we used to do with the whole weapon of the week idea.
Easily.
But when you're looking at equipping infantry with portable munitions, for me, one of the biggest things is the safety considerations. Yeah. In addition to the quality control, the weight, the size, how portable it is, the design, but the safety is huge because you've got to make sure that as you are having folks move these around, they only go boom when they're supposed to. I think that's important. And that's probably the biggest one. I know for Andrew, it might be a slightly different number one, but I'm sticking with your quality control and safety being the most important here.
No, don't get me wrong. Of course it is. Of course it's critical. But that needs to be handled upstream and executed downstream. I get that. For me, it's scalability on this whole thing. Let's not forget about scaling and the supply chain resilience that you've got to have that. You're pushing out a huge volume of these things. And any disruption is going to slow your production down. And that for me is a big risk. Yeah, the safety definitely, but these loitering munitions need to integrate seamlessly with the intel, surveillance, recon systems, ISR systems. They've got to be talking to the Army's intelligence platforms in real time, because you miss that and you're missing and your mission success is on the line, and that's real safety issues.
So, Greg, we've got like one for safety. We've got one for scalability. So you got to break the tie here. What's it going to be?
Oh, safety, hands down. I'm sorry, Andrew.
They all lead into safety, buddy. They really do. And hit scale, then you're disarmed.
No, it's got to be safety first and foremost.
Yep.
Kongsberg Aviation Maintenance Services has signed an agreement with the Norwegian Defense Material Agency to upgrade the Bell 412 helicopters used by the Norwegian Armed Forces. The upgrades are going to enhance communication and nav systems, ensuring that these helicopters are remaining operational until a new fleet is introduced. The first stage of upgrades kind of focuses on civilian communication solutions, while the second stage is really addressing military and communication needs there. The initial upgraded helicopters are expected, I think, summer of next year, with further modifications planned during routine maintenance to maintain operational availability.
Okay, I'm coming in. So the number one challenge here for me is how you upgrade these helicopters without taking them out of service for too long. Downtime kills operational readiness. These upgrades need to happen fast. They need to fit into the routine maintenance windows. Bryan, you know how tricky it is to make sure that everything runs on time without blowing up the whole schedule that you've got.
Oh yeah.
So how do we make sure that it's all done efficiently? For me, it's process optimization, it's dynamic product process adaptation, and it's enhanced material planning. So you've got to get all of this fed through into your MRO as well. So a lot of good stuff in there, making sure your critical thread streamlines that bill of process, pulling through from the original designs, making sure that every upgrade is done in the most efficient way as possible. I don't know. That's my thought.
We also always think about, we know airplanes are huge and they have a lot of parts, but helicopters, they're smaller, maybe, but they also have so many parts that have to work.
1,000 parts, yeah.
Yeah, there's just so much that has to work together with this that, you mentioned the integration and just the planning involved is crazy. It's so crazy that I think it just kind of makes my head hurt and I just need a break.
Kinetic has been awarded a £20 million contract to build a new anechoic chamber test facility for the UK Ministry of Defence. This silent hangar will be located at the Boscombe Down site in Wiltshire and is expected or set to be completed by 2026. The facility is going to simulate electromagnetic environments to test military equipment like helicopters, UAVs, and fighter jets against electric warfare threats such as GPS jamming. There's a number of different things there. This investment is part of a long-term partnership between Kinetic and the Ministry of Defense, emphasizing the importance of robust testing in military manufacturing. I think this is super important. I'm excited about it and really should ensure that resiliency and security.
You just said £20 million contract. That is heavy. I mean, £20 million is a lot of pounds.
Yeah, it's a lot. I can't quite think of how many tons that is, but it's a lot. And that's tons, TONNES, right?
I did that entire thing just to see Andrew's reaction. But no, when you think about it, 2 years of building, that sounds like a long time, but it's also sounds like a short time because we know there's a lot that's going to go into making a new facility. And we've talked about it before on the show where when you're creating a new manufacturing facility, the opportunity that presents to integrate your manufacturing plans, your PLM system into the design of the building is really fascinating. But this is a really cool opportunity to do something similar for testing. So you're thinking, what kinds of tests am I going to run? And you said anechoic, right? Like no sound. This is going to be a silent chamber. But so there's special considerations. What kind of controls? What measurements are we taking? How is the data going to integrate into our PLM system, integrate into that critical thread, tie it all into a digital source of truth? And I think all of that's just really fascinating. And actually the company said that GPS simulators and threat emulators inside the chamber are going to provide the ability for the UK to create a number of hostile environments to test how they can withstand jamming and other threats. So this is just really cool when you think of all that's happening with your testing.
Exactly. A couple of things. I've got a quick comment I'm going to pick up in the chat in a second, but data integration is going to be key. You're generating mountains of data from these tests. How do you ensure that every bit of it gets fed back into the product lifecycle management system to improve your designs going forward? Again, that's going to be test data integration upstream as well as downstream, so bidirectional. Again, you've got AI. You can process all of that data in real time, feed it back into the PLM system, faster iterations, smarter designs. Conan Cullen has just, I hope I pronounced your name right, Conan. It's a complex problem with many competing factors and time is critical. But even the tiniest mistake or mishap can be blown out of proportion and spew in a myriad of ways in the media and budget battles. 100% agree.
That's probably true for every article we talked about.
Yeah, very true. Very true. I mean, I think also let's not forget about future proofing because, this is a £20 million structure. You definitely don't want to be throwing that away too quickly. So you need to get it ready for future proofing. So with every tech evolving so fast, this chamber needs to be scalable and adaptable for threats that we don't even know are coming yet. So how do you get it ready for that? And for me, I'm going to go back to AI. It's predictive threat simulation. So, AI can model future threats like next-gen GPS jamming. So we're testing against tomorrow's threats today. So you've got to build all of that kind of stuff in there. And, you can hire a whole bank full of bright people. But I think if you can start to introduce AI as well, you're going to really help for the future planning as well.
Yeah.
Thanks, Conan.
Lithuania has received over 150 new Joint Light Tactical Vehicles from Oshkosh Defense as part of a significant modernization effort of its armed forces. I'm pretty sure that was a weapon of the week of ours back in the fall. This delivery, yeah, or maybe it was in the spring. I don't know. Time is weird. This delivery marks the second phase of an acquisition program initiated in 2019 aimed at enhancing Lithuania's military capabilities and interoperability with the U.S. Armed Forces. The JLTVs are designed for high mobility, crew protection, safety always important, and versatile mission adaptability, making them a pretty valuable asset in reconnaissance, air artillery, air support operations. I mean, By 2027, these vehicles are also going to be equipped with short-range air defense systems, further boosting Lithuania's defense capability. So I'm excited. It's a challenging environment.
I think this is interesting. I mean, Lithuania's really pushing the cutting edge. They're integrating back into the US. Yeah. Managing the life cycle of these GLTVs, they're getting new capabilities over the next few years. But how do you manage these vehicles efficiently from today's upgrades to future enhancements, like these air defense systems? So, come on, guys, it's pretty tough keeping 150 plus vehicles aligned with evolving technology.
Oh yeah,
going forward. How do we handle that in critical threat? For me, again, requirements traceability, change management first. AI, again, is going to make sure that every upgrade, like those air defense systems, is aligned with the original vehicle specs. No surprises, no conflict going forward. You've got enhanced intelligence coming in on BOM and configuration management. And with all these new systems being added, it's going to keep track of every configuration across the fleet. That's your critical thread. That's your AI that's going to speed up that thread as well, ensuring that every vehicle is properly upgraded without any compatibility issues. And then I've got to say predictive maintenance as well. That's got to come in here to keep these things, again, operational at all times with minimal downtime.
And not just the predictive maintenance, but also the maintenance itself. Once you've predicted it, planning how that goes into these, because this is that same thing we've talked about of vehicles in use that need to stay in use and have as little downtime as possible. 100%. And you're saying that they're keeping to try to make these lighter and more mobile. So how long before I get to put a JLTV on my wall, like on the mount for the TV mount?
Hopefully
anyway,
hopefully soon. Hanwha Systems venture Flexel Space is partnering with Airbus Defense and Space to develop advanced tandem solar cell modules for satellites. These high-efficiency solar cells are designed for various satellite surfaces, really enhancing power generation in space, which we know there's a long way to go there, but I'm kind of excited to hear this development. The collaboration aims to innovate the aerospace sector by leveraging both companies' expertise in solar technology and in space systems. And as the demand for more efficient energy sources in satellite technology grows, I guess my question is, how might this partnership influence future manufacturing processes for solar cells in space applications?
I think it's a really interesting thing to consider, because you're dealing with new technology and advanced technology in an environment where maintenance, like we've talked about so many times today, but the maintenance is really hard to do when you're out in space.
Yeah.
So that predictive maintenance that Andrew's been harping on, I think is even more important here, because you can't just go and replace a part. And, so where do you begin with this? I think you've got to have your testing figured out, your quality figured out, and know that what you've deployed is going to survive the harsh conditions of, the heat from the sun, the little pieces of space debris that ram into it, like, the aliens coming to tinker with your stuff. I don't know, lots of things that could happen that and you don't know what those threats could be. So in planning for this and really trying to figure out how to future-proof your designs is the biggest thing here for me.
Yeah. Durability is everything, isn't it, up there? It's expensive for those things to go down quick, no doubt. So again, it's all part of that critical thread, that simulation, artificial intelligence on your simulation for extreme conditions, material optimization. You've got to analyze all of those suppliers that are out there with their materials, from taking into consideration past missions, similar missions, to choose the very best materials that can handle these space conditions while maximizing, I guess, energy output as well, because of solar.
Yeah, one of the best parts of this whole process is whenever we do the portions of this show that the audience can't see, because we've got like a video playing or a slide up, I get to see Andrew's reactions to my terrible, terrible jokes. And it warms the heart, really. Speaking of such portions, we've managed to finish the news recap for the day. We've got a 2-minute break
for the week.
For the week, sorry. Well, yes, for the weekday. And then we get to dive into a really great critical discussion with Lewis. So stay tuned. All right, everybody, welcome to the critical discussion portion of our show where we're joined by Lewis Breeding. He's a technical account manager with XDI with over 20 years of experience consulting with defense.
Yeah, he's come to us from Spirit, Northrop Grumman, Sikorsky, Boeing Defense, just to mention four. I love working with Lewis, and I'll tell you why I love working with Lewis, because Lewis, as a design and engineering and product lifecycle guy, gets why he does what he does, which is to get things into manufacturing at speed with quality, not perfectionism back in the design and engineering place. He knows it's about when the rubber hits the road, and where it goes beyond a fantasy and into reality is when you build it. So love working with Lewis. Welcome to the show, Lewis.
Hey, thanks guys for having me on.
Yeah, thanks for joining us. We appreciate it. And we're going to dive in. We're just going to dive right in. So let's talk about, I don't know, in say aerospace and defense.
Design and change management today, Lewis, isn't it?
Yeah, I think so.
Yep. Good.
Yeah, that works. Design and change management in A&D. Let's go. That sounds like a good topic to just randomly throw on somebody and their, after their morning Friday coffee. So Lewis, with all that in mind, how do you see the integration of CAD management and model-based design impacting the speed and accuracy of the detailed product design that Andrew was just talking about?
So speaking of MBD, right? MBD is it's model-based design. So it's taking that 3D GD&T data or PMI data and putting it into, your CAD itself, right? So the accuracy is going to be far greater when you're integrating that, because you got the reduction of misinterpretations, right? You got the ability to rotate the model, filter out, what needs to be filtered out and seen. And really, it's just that kind of accuracy, taking this surface needs X, whatever it is, right? And pointing that out in the 3D, that's just the type of accuracy you're never going to get from looking at just a 2D drawing, right?
Okay. Yeah, it's visualizing from 2D to 3D in your mind is much harder than visualizing from 3D to 3D. That checks out. That makes sense.
Sure.
So
I started out with 2D, right? And defining all of this type of stuff, right? Obviously, they don't even teach that in school anymore, right? It's everything's 3D, right?
Mm-hmm. There's undeniable benefits. I get that, given the kind of accuracy highlighted with this whole 3D model-based design integration, especially in terms of quality and manufacturing processes. But what do you actually see as the main challenges that smaller suppliers face in adopting this approach?
That usually comes down to, if they're the smaller suppliers, what is that delivery, right? If I'm a build to print shop, I may not necessarily have to deliver, but I've got to build to that, as it comes in, right? Mm-hmm. So, it's cost. Let's face it, we're all in business to money, right? But there's cost when it comes to, implementing that if I'm a small build to print shop. Now, the tier ones, the tier ones are typically delivering, and getting that stuff built, from these build to print shops. But the tier ones may have to, actually do the MBD side of things, right? Mm-hmm. And then, if you are a shop, whether it's a tier one or whether you're a build to print shop, typically like say like a Dassault Systems, right? Mm-hmm. An OEM of like software, right? They'll deliver and they'll allow packages to the smaller companies, right? That are based off of what are the Boeing standards, what are the Airbus standards, right? Yeah. And you can buy that at like a discounted cost, right? And that's entirely up to the company how they choose to implement it within their organization.
Yep.
But again, it comes down to what is the deliverable.
Is it a skills issue as well? Do they have the skills further down the supply chain to adapt to the 3D MBD models?
Yes, it is. A good GD&T guy, right, mm-hmm. can look at that stuff and doing tolerance stack ups and tolerance analysis and all of that kind of stuff. There are tools out there that help when you're doing it in 3D, right? Yep. Sigmetrics is a good, one I can think of that's like a third party, right? And they offer, the ability to see that and visualize that in 3D. When I'm telling it, I got this much here to here with this much float, what does that actually look like 3D model,
Right.
the ability to see that. 2D, it's a lot of calculation.
Yep. So do you think there's more that the OEMs can be doing to enable their supply chain, their ecosystem to pull through 3D MBD stuff?
It's hard to say. From an OEM level, they're going to say this is the deliverable that we need, based off
Okay,
of
no
whatever
problem.
for their program, right?
Yeah.
So ultimately, it just comes down to, are they going to give them the money to invest into that, right? How much business is coming?
Or for guys like us to get with those customers and show them that it's not as expensive and it's not got the lead time
Right.
that they might be thinking. Yeah. Okay.
Yeah.
Okay.
Agreed. I mean, yeah, we do that all day long, right?
Agreed.
Because a lot of the smaller like build to print shops are hesitant to invest a whole lot to like this level of MBD you're talking about, because it sounds like it's going to be an expensive process that might not pay for itself.
But it's coming.
Right. And it's coming. Yeah, it's already there, right?
Yeah.
Yeah.
Let's face it.
Yeah. So as we look at this idea of the change management process integrating into the digital thread, we know that that's crucial for maintaining design integrity. So how can you ensure that the context and justification for design changes are accurately communicated across all the stakeholders, especially when dealing with, complex supply chains?
So it's all about communication and collaboration, right? I mean, that's number one, right? Your change, it's got to be managed somewhere. Let's face it, right? And if you're managing it somewhere in silos, not going to be the best idea, right? Manage it in some kind of environment where everybody has access to that, right? That is the whole concept of digital continuity, right? Keeping stuff in as little place or as little amount of silos, and having everybody need to be able to access, right? Any change has got to be concise. It's got to be clear. You got to involve all your stakeholders and have everybody at the table when they need to be at the table, right? But you also need to be able to track back what's been done before.
Mm-hmm.
Yeah.
Right.
Yeah.
So that's where it becomes easier to manage when you look at, like, again, Dassault systems, right? And 3D experience platform, right? It's more than a PLM, right? It's a platform that allows people to come in and see what they need to see and participate.
Yeah. Business platform. Agreed.
With platforms like this, do you feel like in your history of 20 years of experience working in this area, right? So do you feel like you've seen benefits happen where this ability of a company to see this history for all the stakeholders to actually see access to the data, where they used to be maybe more siloed or even hindered by the different softwares in each department trying to talk to each other? Have you seen a lot of changes and improvements based off of that, do you think?
Absolutely. I mean, when you've got stuff centrally located in one place, right, and you're not trying to go find things everywhere else, of course, right? You see the purpose of the change. What is the change? Are there any issues with it? What are the impacts? Right? All of that type of information, getting it to the right people at the right time, right?
Mm-hmm. What kind of strategies or best practices do you recommend to ensure that all the stakeholders, particularly those in the external supply chains, are effectively engaged and aligned?
You got to give them access to the data, right?
Right.
And when we're talking ITAR and we're talking, that type of stuff, right? That's a no-brainer.
Yeah.
Right? But having them come and see what they need to see is very important, right? Whether it's through some portal or whatever, but they have to have the information and they have to be able to collaborate back and forth.
Yeah. Yeah. I remember I was in a workshop about a month ago, and I think it was someone in procurement was bitching and whining, saying, "Oh, I've used this platform and it isn't very friendly." And it's just screaming out as well that nobody sat down with her and educated her, trained her, showed her how to navigate and to get around. And then I remember it was like 2-3 weeks later, somebody did exactly that. And she just turned on a dime and said, "Okay, now I know where everything is." It suddenly becomes a lot easier for me to work. So I guess I was going to say, so how do you address potential resistance or challenges in ensuring that PLM becomes the central hub for collaboration?
Well, to quote my inner Trekkie nerd, the Borg say, resistance is futile.
Okay.
But in all seriousness, right? My experience working with implementations of the different types of PLM systems over the years,
Yep.
there's never going to be 100% acceptance overnight. It just doesn't happen, right?
No,
It's in any type of business, any change is big, right? It can become a big deal, and so having people to try accept a new way when they think the old way worked better, sometimes that clashes, all the time actually. That clashes, and it becomes a matter of like good leadership will communicate, right? But there's different ways to communicate, right? You want to communicate in such a way that you're involving them instead of telling them, right? It's those people become your champions, right? It's not I'm doing something to you, it's what can we do to kind of get this done.
Yep.
Right.
Yep.
And when we look at like OCM, right, it's a big topic. But, if it's a large company, OCM makes the most best sense because you're communicating right out to everybody.
Mm-hmm.
And you're looking for that kind of feedback mechanism where everybody feels like they're involved. Right. Mm-hmm. As opposed to, oh, great, here's the next thing they're going to put down. Right. We can go on about that. But if you're looking at top down, usually doesn't work, right? Management says we have to do this.
Yep.
It's semantics, or it's the different way of looking at things, right?
Right.
So you're saying if the captain says to do something, you might do it, but if you feel like you're part of a team, in the enterprise bridge, and the captain says to do something, but you want to help as well because you're all part of the same team, it's going to work much better.
Absolutely.
To extend that Star Trek analogy. And Star Trek actually brings to mind data. And I think data is probably one of the more, I'd say, characters with the most integrity, right? So when we look at data integrity, vaulting and indexing 2D and 3D models is essential for data integrity. What are the biggest challenges you've encountered in maintaining data integrity, and how do you overcome those, particularly in aerospace and defense?
So it's not so much about, to me, it isn't so much about like vaulting the data. That's just a PDM system out there somewhere, right? Where you're really trying to get to is, BOM type stuff, right? What is the relationship between that CAD model and what's the engineering version of what's that CAD model?
Yep.
Right? Vaulting, engineering can go on and on and on, right? Traditional file-based systems, last to save wins, right? If that, directory is there, right? You really want to get to what is this model? How does it relate to that particular rev level of that, of that engineering item? And then from there, move it to, get into a situation where you're not with these non-regulated, because CAD just keeps going, right? So you got to start to build for digital continuity. You got your requirements, and then you've got your CAD, but you got to start tying that to what is the engineering bond, right? And then we'll take it from there. Now, how I help companies, right, is with 3D Experience Platform, and this isn't necessarily a commercial for it, but it does a really good job of linking all of that stuff together, right? And it's built in such a way that that's my EBOM, right? And it's not taking it from this, and then I've got my Excel, and that's my EBOM, and then I take that Excel EBOM and pass it over to manufacturing, whatever they're doing, right? That becomes disjointed. That's not digital continuity, right? You want your CAD connected to your EBOM connected to your MBOM connected to your process plans and resources, and let's get it out the door all the way.
Yep.
In one central location.
Yeah.
Yep. So, I mean, I agree. You emphasize the importance of linking your CAD BOM, your EBOM, your MBOM, your bill of process, your process plans to create that seamless critical thread. In your experience, what are the most common challenges that organizations are facing today when establishing these connections across the life cycle, particularly when you're integrating with existing manufacturing processes?
So looking at that, it's model everything, right? And I don't necessarily mean model in CAD, right? What I'm saying is like, if you're a company and you have these processes, right? You're taking your CAD, you're linking your EBOM at this rev level to this version of that part at that rev level,
Mm-hmm.
and then taking that digital continuity and spreading it all the way through, right? It's not an Excel sheet going around, right? Traditionally, when we've done, what we've seen in the past, right, is they'll take, engineering will take that MBOM and then reorganize it, right? Because it's not structured in such a way that MBOM needs it, right? But they still have to consume every one of those parts, but they build their own version. Today, bombs are universal in nature, right? When we talk bomb, but really they need to be linked, right? They need to be tied together so that if a change happens, because God knows that could destroy a company, right?
Yep.
If a change happens and I'm already cutting titanium to something, you better hope I haven't cut off enough when I realize that, too much, and that's the wrong version of the part, right? That's the biggest challenges we see, right? Is that non-synced environments, right?
It's an organizational culture a lot of the time, I think, isn't it?
Yeah.
It's a silo culture. I mean, you have departments, you have heads of departments that are thinking very much vertically rather than horizontally in terms of a process flow. So absolutely. And the more we communicate about a thread and it being seamless and it being bi-directional, the better, and people start to change up as well. But it has to cascade through the enterprise as well. I agree.
Well, and Lewis also touched on the fact that information has to be quick and timely, and you can't find a mistake in quality and say, I will tell them tomorrow, and then they've already, as you say, cut all the titanium up, right? So like you've got a accurate and quick communication of the proper data.
Right. And if you think about why I even went to CAD to begin with, right, was to do things faster, right? And when you have a good flow and processes and all of that type of stuff, like ironed out already, you can reuse that, right? I mean, that was the whole reason behind going to CAD to begin with.
Yeah. Yeah, that makes sense. So you're talking about critical thread in general here, and about how you've got to have it be robust and adaptable. So how are we ensuring that the critical thread remains adaptable to changes without disrupting the ongoing operations?
So like I said before, it's a journey, man. You got to start small, right? And get a hold of those main things, right? Engineering, manufacturing, change management, right? That's the easiest place to start when you're disconnected, right? And to be able to, day in and day out, I talk to people, right? That's what they need, right? Because getting out of sync costs money, right? And not having the right parts on the floor, then that can get into an entire discussion, about ERP and having everything in one flow. That's where you want it, right? You got to analyze that and map that out. We do that for all companies, all the time.
So I think it's fair to say I'm starting to kind of see what you're saying, get a good picture of this process. And it's also fair to say that visualizations are used to enrich the digital thread. So
Absolutely.
Enhancing, I guess that understanding across all the teams, how do you balance the need for a detailed technical visualization with the need for broader, more accessible visualizations that can be understood by, let's say, the non-technical stakeholders?
So the old saying, a picture's worth 1,000 words. If I can give you a 3D CAD model and you don't have to have a CAD system to open it and it's live and it's connected to everything, that's beautiful, as well as the ability to see the BOM and how it's structured and everything else, right? Marketing people, they don't really care about, the engineering bond. They care about how it's rendered and how it looks and, all of that type of stuff. So, 2D drafting, like I started, and 2D board modeling and stuff, and where we've come over the past, we'll just say 30 years, probably been in that a little longer. But, like I was saying before, we don't really teach that 2D stuff anymore. If I can give someone that ability to see that, and again, not a commercial, but, in 3D experience platform, when you look at this, as models are saved, light models get built. And this is all, the user doesn't see any of that. And I don't have to give that user a CAD system because I got the ability now with Access to see a visualized, a small, what we call CGR, right, in a web browser. And I can do measurements, I can cut sections, I can hide parts, I can show parts. Giving people that kind of access greatly improves that ability.
And it's fun watching their excitement when you show somebody who doesn't have a huge, CAD system on their, they don't even have the licenses or the installation of it. But when you tell them you can just click on this browser, pull up this CGR and actually see this, really quickly see this. I see light bulbs and actual excitement in folks when we show them this and when it's implemented. I think it's a super cool thing.
Yeah. And you start getting into multicad and having other systems that have connectors, and have the ability to read NX data, the ability to read Creo data, the ability to read Inventor data in a multi-mixed environment, and looking at, stuff designed in completely different CAD systems, the ability to interact with all of that instead of the traditional, well, I guess we'll remodel this or we'll step it out and try and read it again, and all of that. It eliminates all of that, right? All of that overhead that used to cost a lot of time, right? To have it visual.
Lewis, how do you see it evolving over time now? I mean, there's obviously advantages of 3D models in communication, collaboration, but how do you see that moving forward now within cross-functional teams?
It's a great question. It's hard to say, right? We're seeing a lot in the CAD, a lot in the AI, a lot in a lot of different things, evolving, but it's definitely a lot easier when you can share information that's live all the time, right? The ability to not have to email, right? The ability to be able to go inside the ability to do like Teams messaging, right? And visualizations live, right, with the CAD and the designer, as well as, and be able to capture all of that as well, right? It's all there today.
Yeah.
Just a lot of people and a lot of companies don't know the power of like how far we've come.
Yeah.
Right. Good. Yeah. Okay.
I think that it's probably a fair statement to say that we're seeing the aerospace and defense industry adopt the digital thread concepts. You see that more and more every day. And if you've been paying attention to the discussions we had about the news earlier, one person on the screen is really excited about AI.
Yeah.
And so at least one. And so how do you see, Lewis, the technologies like AI and machine learning playing into the evolution of design and change management process, and how those are going to enhance current workflows?
It's a little bit of a tricky question because none of us know what AI is actually doing, right? But to really look at it, AI is just another toolkit, right? It's great. It's improving accuracy as far as like what are the actual requirements of the design. When you look at like some of the generative stuff, which ties in basically mod sim, it's modeling and simulation, and then doing like optimization. There's a tool within the CATIA platform, right? I'll just speak to the CATIA platform that will, it's called functional generative design. And what that will do is actually like, I can model up just the bare minimum of something, right? And then I can tell it, these are the stresses, these are the loads, this is the lightness, this is all of that. And then on top of all of that, right, not only will it come up with a design, but it'll do it in 3D printing style. It'll do it if you want it as a machine part, if you want it as a casted part. and it will actually show you, based off of that criteria, these are all the different options. This meets this meets that, and it becomes the trade-off, right? And then you take it from there. I mean, back in the day, it was like, well, it needs to be lighter. Okay, we put holes in it. It's stressing. Okay, we'll make it a little bit thicker. Right? All of that. You don't have, like, design and simulation are traditionally two different areas, right?
Yeah.
You're saving all this CAD data, and then you're passing it over to the simulation guy, who then starts his analysis. By the time he comes back and says this part's wrong, that whole area could be redesigned, right? It's about getting them all together, as well as the designer doing, and that's where I was talking with the mod sim, right? The designer doing a little bit of simulation on his own as well, right? So with or without AI, that's kind of the key. But the AI is the cream, right? You know, it's the cream of the crop, right? It's saying, here, this is the best design based off of the inputs that you gave me. But it's not perfect. Right? Nothing ever is perfect, right? You can't.
Oh, it's getting better. I think there's other ways as well now, aren't we? Along the generative AI side of things, which is predictive change impact as well. So you're able to forecast forward what a change might do in the future, as well as a new type of design. So it's getting really exciting going forward, especially for the defense, aerospace and defense sector.
Yeah, when you look at like what we were doing back in the, I want to say back in the V5 days, just because I've been in, 3D experience CATIA for many years now, but that was templating back in the day, right? You would make templates that could, how does this part usually change, right? And how would you take that template and try to adapt for that change?
Yeah.
Right. And so it just becomes, again, the AI can predict that, and maybe you can see that a lot sooner.
Yeah.
Right. It's only as good as the information you give it.
Yeah.
Its algorithms are only going to do so much. Back in the day, we had checkers that would always look over stuff. They understood it. Right.
Well, ML algorithms, yeah. But these new open AI things are real interesting. So last couple of things for me, with these powerful tools now at all of the designers' fingertips, I mean, this is something we're introducing every day. How do you balance the role of automated design generation with the need for human intuition and expertise? There's one for you.
Yeah. Human expertise is always going to be needed, period, right? I mean, I'm not going to be like the guys back then that said, oh, this CAD stuff will never work, right? But you just can't trust an algorithm, right?
Yeah.
I go to ChatGPT and say, give me the Python code for this.
Right.
It'll spit out an output, but it's only as good as its intelligence, right?
Yep.
I have to physically code that and see, right? Does that work, right? So there's always going to be a need for some type of human interaction with it.
Mm-hmm. Mm-hmm. For now.
Exactly.
Good. Thank you, sir.
Yeah, I think was a pretty informative little piece of tidbits of information probably hidden here. And honestly, the best part is whenever you get to somehow make Star Trek references while talking about, PLM and engineering. I mean, that's the highlight of the show, really.
Yeah,
for sure.
Thanks, Lewis.
Lewis, thanks for joining us. Andrew, thanks for telling us some news. And of course, Greg, thanks for giving us all the headlines earlier. And we hope everyone enjoyed the show. We'll be back next week. Same bat time, same bat channel.
You bet.
Yeah.
We'll see you next week. Have a good week, everyone.
All right. Thanks, everybody.
Thanks.